Hey, honors pre-calcers, this is section 7.3a, trig equations. So let's get started. First of all, you had a warm up at the top of your notes. Go ahead and pause that video, try to get these two answers, and then come on back to me. Next up, learning target today, we're going to be solving for angles. So we're solving for angles in trig equations. These directions are always going to say the same type of thing. It's going to say find theta, and they're going to give you some boundary. And here they're telling you theta is in between 0 and 2 pi. So we should think, okay, one time around the circle, we need to solve for all of the angles. Now in math lab, just a little note, sometimes they're going to say find theta, and they're going to give you degrees here. So just watch out. That means that it's going to want degree answers. But in our notes, we're going to go all radians. Here we go. This says 2 times the sine of theta plus the square root of 3 equals 0. I'm trying to isolate my trig values first. So I'm going to isolate that trig first. Okay, so to get this sine of theta alone, I'm going to subtract the root 3 over to here. And then I'm going to divide by that coefficient of 2. All right, so now my brain thinks, where are all of the values one time around the circle for theta, where the ratio, the trig ratio, is root 3 over 2? And so the first thing I think is, well, where should I draw my triangles? A super trig class, I know that sine is negative in quadrant 3 and quadrant 4 because that's where y is negative. And remember, sine is y over r. So I'm going to draw my triangles in quadrant 3 and in quadrant 4. Now sine is opposite over hypotenuse, so I'm going to write my opposite leg of theta being negative root 3 and my hypotenuse being 2, and right away I recognize that triangle. I recognize that triangle as a 30, 60, 90, where this angle here would be a 60-degree angle. But remember, we're thinking in terms of radians. So right now I'm going to label this as pi thirds. I know that this guy here is 3 pi thirds. So one of my angles, theta, where my ratio of the sine is negative root 3 over 2, is going to be at this angle here, 3 pi thirds plus another pi thirds, 4 pi thirds. All right, and then we also need the angle that goes all the way around to here. Well, right here, all the way around the circle would have been 6 pi thirds or 2 pi. So one shy of that, this angle right here is 5 pi thirds. Now, those of you that have been rocking your trig quizzes in class, those timed quizzes, you won't even have to draw this picture at all because you know that the sine is root 3 over 2 when the angle is pi thirds. And then you just have to figure out, well, what quadrants do we want to be in when we go one time around the circle? So knowing those trig ratios is going to speed up these assignments. Let's do it again. This says the cosine squared of theta equals 1/4, and I want to get theta alone eventually. But first, I'm going to isolate the trig. So I'm going to get rid of the second power by taking the square root of both sides. Now, do not forget something that we've been working on. Whenever we square root both sides, we need to remember that there's potential positive and negative answers. So when you square root both sides, plus or minus is going to be huge in this chapter. I'm going to have the cosine alone, which is great because that's what I wanted. I get positive or negative. I'm going to take the square root of 1 and I'm going to take the square root of 4. So that is going to be positive or negative 1/2. All right, those of you that have this memorized, you are already good to go. You already know my answers. But if you don't have these memorized, and there's some of you that don't yet have these memorized, then you're thinking this. Hey, positive cosine is going to be in quadrants 1 and 4 because x is positive and cosine is x over r. And cosine is going to be negative. Here, look, I'm going to have 4 answers because of that plus or minus. Then you would have to draw those triangles. See what a bummer it is not to have these things memorized? Cosine would be adjacent, and this would be hypotenuse. And now you recognize your triangle as your 30, 60, 90, or this would be the square root of 3. Now this guy here is across from that root 3. So again, that's pi thirds. 60 degrees or pi thirds, but I need pi thirds in all 4 quadrants because of that plus or minus. So my final answers are going to be in quadrant 1, pi thirds. In quadrant 2, well, let's see, this guy is 3 pi thirds. So in quadrant 2, I'd be up here at 2 pi thirds. In quadrant 3, I'm going to be down here at 4 pi thirds. And then all the way around the circle, remember, this is 6 pi thirds. So I want 1 shy of that, giving me that 5 pi thirds. Before I flip the page, I just want to make a special note about this problem. Notice that this right here, the original problem, had this cosine squared. It's very important to note that the cosine squared of theta is the same thing as the cosine of theta in that quantity squared, or cosine times cosine. It is not squaring the angle. So it is not the same thing as cosine of theta squared. You are not squaring the angle, okay? Cosine squared of theta means cosine times cosine. So just a little side note there. All right, flip that page here. Again, those of you that memorize these values, gosh, those are going to be so much faster. Okay, now I'm going to use a calculator. Why do I need a calculator? Well, it says, what if we don't recognize the trig ratio? So we're going to use a calculator, and because this is saying between 0 and 2 pi, notice this is just interval notation. It includes the 0 and it excludes the 2 pi. So it's no different than my directions on the first page that said my answers can be in between 0 and 2 pi, include the 0 with this equal sign, and never give 2 pi as my answer. Okay, same exact directions here between 0 and 2 pi. So notice this is the sine of theta equals 0.3. I don't have that memorized. It's not like a 1/2 or root 3 over 2 or 1 over root 3. It's nothing that I have memorized. So that's why we need our calculator. But we actually need to be smarter than the calculator, because when I go to my calculator, let me start a new document here. Okay, first of all, notice this is 0 to 2 pi. So I actually do have to toggle back over here to radian mode. So I toggle that to radians. All right, and then this is the sine of theta equals 0.3. So I'm going to ask the calculator where the sine is equal to 0.3 by taking the inverse sine of both sides. We know that from last chapter. If we're trying to solve for the angle, we're going to ask the calculator for the inverse sine. All right, so here we go. I'm on radian mode because of the directions, inverse sine of 0.3. Now the calculator is going to give me this number here. And this number here is a crazy decimal in terms of radians. So I need to back up for a moment and remind you that in a circle, we have 2 pi radians all around the circle. Well, we've never really thought about what that means. 2 pi radians is about 2 times 3.14, so about 6.28. And then this guy here is pi radians. This is 3.14. And going up, that's about 1.57 if we were to do all of these in terms of decimals. So this would be a 3.14 plus another 1.57. So down here, about 4.71. Notice I have not changed. This is just radians written like decimals, which is funky. And the calculator gives that decimal to me. It says, oh, I know the angle that you want. The angle that you want is 0.304693. And we say, yes, but the calculator did not know the directions. The directions were to go all the way around the circle. So remember when I said we have to be smarter than the calculator doesn't know the directions. The calculator only gives me this quadrant 1 answer. And I have to say, I also want that quadrant 2 answer because the sign was positive. So if you're taking a look at the picture, the calculator just gave you 0.305-ish right there. And we have to say, yeah, but we want 0.305 here. Okay, how do we calculate that? Well, all the way to here would have been a pi. So I need to take pi and subtract that number on the calculator. To do that, I'm going to press this pi button here, pi, and I'm going to subtract. I'm just going to grab that answer there. And so my other angle is that 2.8369. Okay, so we have two answers, 0.3 and then 2.8. And how many ever I think they might want 4 decimals actually. So how many ever decimals they ask you for. Be smarter than the calculator because you know the directions. Okay, let's try another one. So this guy says, I'm using a calculator to solve between 0 and 2 pi. All right, so I'm going to take the inverse cosine of both sides. So I'm going to ask the calculator for the inverse cosine of negative 0.38. Now, before I do that, I'm going to make a prediction. It is going to give me an answer, ASTC, where the cosine is negative, where x is a negative number. So it's going to give me this answer or this answer, and whichever one it doesn't give me, I need to give. So I'm going to do that here. Okay, and so I'm going to go cosine inverse like this of negative 0.38. And it gives me that 1.96. All right, so look at what it gave me. 0 to 1, we'll say 1 for 4 decimals. Okay, so it gave me, if this is 3.14 and this is 1.59, it gave me this quadrant 2 answer. Why? Well, the previous lesson we learned about was inverse trig functions and where the calculator will give me the answer. And when cosine is negative, cos in a second, remember, from the previous answer, it's going to give me this answer here, not that one there. We have to be smarter. We have to say, hey, but calculator, this directions wanted me to go all the way around. So my picture looks like this. This guy here was 1.96-ish. I need to give this one here 1.96-ish. Okay, so I'm going to take that pi and add that 1.96. So on my calculator, here's my pi button, pi, and then I'm going to add, just grab my number there. And so my second answer would be 5.1022. Okay, and these are angles in radians. So I don't write radians. I definitely don't put a degree symbol unless I was in degree mode. And Math Lab, again, will ask you for a degree mode. All right, so I have a few examples here I would like you to try. Check in with each other. Make sure you've got this and watch back if you don't.